Hi there, welcome back to my YouTube channel. It's J Asukwo. It's still Golang for beginners. And if you have been following, we have been talking about the blockchain series. I think this is video 5 right now, and our last video was how Ethereum wallets and private key behaves on in blockchain, right? So now for today we are going to actually try to send out Ethereum with Golang, right? So when you're talking about being a blockchain developer, like I have explained in several videos, it's not just about writing smart contracts. It's also about connecting to the blockchain and being able to carry out things on the blockchain, carry out transactions on the blockchain, read transactions and carry out transactions. So in this video, we are going to connect to Ethereum, which we have done before. I think in my first video, we were able to connect to Ethereum. So if you haven't watched it, this is just a recap. We are going to load wallets, and I think we have, so most of this thing might just be a recap of what we have done in previous video. The main thing starts from creating a transaction, signing it, broadcasting it, and verifying it on our Sepolia Explorer. That's we can always go and verify all blockchain transactions somewhere. So we are going to verify that using, because we are using Sepolia, so that's what we're going to use to verify it, right? So let's keep going. So now, like I've said, what we have been doing in previous videos, it's basically we have been reading from blockchain, so we have not really had the need for any signature. So it was the last video, the video 4, that we talked about private keys, because it's private keys you're going to use to sign transactions. So to read from a blockchain, to read a blog, read accounts, read transactions, we don't need you to sign it. So we don't really need your private keys to sign it, and we have done this in previous videos. Please, like I said, always try to check out previous videos so that you can follow along perfectly well. So for today, we are going to create transaction, which is more like modifying on a blockchain. You're writing to a blockchain, you're modifying the state of a blockchain. So you're going to create it, sign it, and broadcasting. So now let us we can see here down here, reading is free while writing requires ownership. So anybody can read, anybody can have access to what's on the blockchain. You read it, but for you to be able to write to a blockchain, you must have your private keys to sign what you're writing, and this usually costs a gas fee, which we are going to, I don't know if I've explored gas fee in previous videos, but we are going to talk about it in this video because it's needed for transactions, right? So now, what happened when you send ETH? When you send ETH, is quite easy. You have your private key, you create a transaction, then you use your private key to sign the transaction, then you broadcast it, and then validators look at that. Validators, people that are interested in mining blocks in blockchain, they look at that transaction, confirm it that okay, this transaction was signed by the right private key. And how do they do that? They have access to your public key in that transaction, so they can defer which they don't know the private key that signed it, but they would know based on that public key that yes, it was signed by the right private key, right? And then if they validate it, they put it in the block, and then the recipient receives its ETH or is block is crypto, right? That's basically how the flow is, right? And then, so for every Ethereum transaction, it contains the sender, the receiver, the value, that's the value in ETH or in GUE, like we've discussed in previous video. GUE is to ETH what cent is to dollar, or what kobo is to naira, right? So the value, the nonce, we've also spoken about nonce in previous video, which is like the amount of transaction, the number in which you're about to transact. So nonce is like the total transactions you have made on your account, right? So we're keeping track of, we use that to send transaction and also send transactions, so that to to prevent something called replay attack, so and other things. I think I've treated that in previous videos, so you might need to check out previous videos too. So now you also have the gas limit, the gas price, and then the signature. So basically the gas limit, yeah, it's basically what you're willing to pay for that transaction, right? And then the gas price is basically the gas price is it can be a confusing concept, but just stick with me. We are going to get it. We're going to build it and then explain it along the way, right? So now, the steps to creating a transaction, right? We have literally shown this on previous videos. So right, this is just take this as a recap. Take this as a recap to what you have already practiced, what you have already known. So if you haven't practiced or known it, please do well to check it out, right? We connect to the Ethereum, which we have done this with our RPC URL. If you don't know what RPC URL is, please check the first video of this playlist, right? And then we load your private key. So usually your private key here is this is something you load this private key hex from your env. But for this video I created a new account, a new account, and we found out how to get the private key from the account that was from the previous video, and that's what we are going to use it here. I'm not going to put it in environment variable because I don't use the account for anything. It's just for the purpose of teaching and this video. So feel free to use it if you want to, but I would advise you create yours and put yours in an environment variable, right? And then you call it here as your private key X. Now you derive your wallet address. So right now your wallet address, that is if you're going to be sending Ethereum or whatever to someone, you have to be sending it from your address. So from your private key, from your priv key, which you are going to derive from this number 2, you can use that priv key to also derive your public key, and then you can use your public key to derive your address. You can derive address of the public key, right? So, and that is going to be your sender's address, and then from your sender's address you can get the nonce, the next nonce that you're going to be sending, right? And you pass it into the transaction as your nonce, right? Now number 4, you get your next nonce. This is, like I said, this is a transaction counter. Every transaction is increased. Every transaction increases it by 1, and I've told you before in previous video, and I think I just mentioned it now, that it helps prevent replay attack, right? If you don't know what replay attack is, please contact next video, my previous videos. So now you choose a recipient, like you're sending it from one wallet to another wallet, right? So you choose a recipient that is going to receive it, and then you specify the amount. So 1 ETH is basically 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. It's basically 10 raised to power 18. That is way, they call it way, 10 raised to power 18 way. So that is 1 ETH, right? So you take note of that. So when you see it, you just know that you are taking it in wave form, and that is what we send, right? In wave form. You don't just send 1 and think you're going to get 1 ETH. It's like trying to send 1 naira, but instead of sending 1, you're sending 100, because it's 100 kobo makes 1 naira. Same thing with the cents, right? So then we have gas. Like I said, gas, we have get and set the suggested gas price and your gas limits. So 21,000 way is enough for a simple ETH transfer, right? So you, like I pointed out in the previous video, you set your gas limit that you are willing to pay. So in this one you can set 21,000 because you know that it's going to be enough, and then you're going to, so you might get the suggested gas price from this code to do that, right? Or you just, so the suggested gas price, because this fluctuates depending on the state of the blockchain, it fluctuates, so you might need to get the suggested gas price and then put it in the transaction that you're trying to send out, right? So now the next thing for you to do is to create a transaction. You literally form the transaction, which is what I showed, the transaction I showed there. So to form a transaction, you pass in your nonce, your to address, the value, the gas limit, the gas price, right? And then so data might be nil, right? This is data. You're not really sending any data. You're just sending the value. That is what the crypto you're sending, right? So at this point, the transaction is not signed. So you can see that this transaction is not signed. So for you to sign the transaction, right? Before you sign the transaction, you need to get the chain ID. So this chain ID is just a unique identifier assigned to each blockchain network, right? So how will I put it now? Blockchain is like you're trying. So it's like you have Naira and you want to send money to USD, right? In a blockchain network, you have to. So you're sending Naira to Naira. So you have to kind of specify what currency, and that is specified by the chain ID. For example, the chain ID for Ethereum mainnet is 1. So if you are dealing with Ethereum mainnet, you'll probably be using chain ID of 1. So it's so that you are not trying to send Ethereum to, so that you are sure you're not trying to send Ethereum mainnet to maybe Binance or Bitcoin, right? Mainnet, or you're not even trying to send from Ethereum mainnet to Sepolia mainnet, right? So this is things you take note. But we're not dealing with, for this video, we're not dealing with Ethereum mainnet. We are connecting to test environments, test nets, which is we're using Sepolia. So let's take note of that. So we are going to derive the chain ID of Sepolia, and then we sign the transaction with using that chain ID and our private key, right? That's how we're going to sign the transaction. You get the transaction. This is a transaction that you formed here. You're going to pass it in there with the chain ID and then the private key, and then it signs the transaction. So only the owner of this transaction can produce a valid signature, right? So only that. So as long as you have your private key, you're the only one that can sign this transaction with your private key, right? So the next thing would be, after you sign it, you broadcast it out. So you're broadcasting it is sending the transaction. The transaction is now, so it's sending the transaction, right? The transaction is now sent to Ethereum network, right? So the Ethereum network you have, so it's just, we're going to see this thing play out how it's supposed to play. So you're just sending it out. The sign transaction that you sign, you just send it out, right? And then you can now verify the transaction. You can now copy the transaction hash and paste it on your Ether scan, right? In your Sepolia Ether scan, and then you'll probably see things like pending, confirm, the block number, the gas used, and everything about the transaction, right? So the complete flow is this. You get your private key from your wallet address, right? You get your private key from your private key. You can get your address from the private key. You can derive your nonce from the same wallet, from that wallet address. You can derive your nonce, and then you can get the gas limits, and then the suggested gas that you're supposed to use for that transaction. And then when you have everything for the transaction, you form a transaction, and then after you create the transaction, you now sign the transaction using your private key, and then the chain ID of to signify the network we're dealing with, right? And then after that, we broadcast it, and then after broadcasting it, we check the transaction hash, right? So like I've mentioned before, right now you might see the private key in there because, like I said, I'm using this to teach. Usually you have to store it in an env file, or keep your private key secret. Don't let someone have access to your private key, or they can have access to your account and follow quite the same steps to send the money from that the money that is controlled, the crypto that is controlled by that your private key, to his own account or his own wallet. So please, let's keep that in mind, right? So now back to the code. Let me see if I can increase this, take this out, increase this. All right, like I said, a lot of this would be would probably be a recap for a lot until we get to the part of creating creating transaction. Like we know how to connect to the clients through our RPC URL. Like if you don't understand this, you might need to check out the first video on how we derive the RPC URL. And then we have, and like I said, we are using Sepolia network, right? We are using ETH Sepolia network here, not the mainnet. So we're using it to test. And then from our previous video, we knew how we got our private key. This is the private key we got here. Clear this. So this is our private key. We got our private key. So now you see I made a note here, load private key. So it's supposed to be like in your env that you load it. So like I said, you get from your private key hash, you get your private key, and then from that you can get the public key. So you're deriving the public key, so that because you want to use the public key to derive the form address. So you derive the public key here, and then you get your form address from your public key, right? It's a mathematical formula. It's a mathematic formula. You can, if you love mathematics so much, you can search on it. I am not going on that route. So I'm just teaching you how to follow it out with code, right? So yeah, you can confirm your from address, right? Now, this is my to address. I'm going to send Sepolia from that private key, from the address that we set up, from the account we set up last time to my own personal account, right? It's Sepolia. So I'm just gonna send it out, right? Get it there. So this is gonna be my own personal address. So I mean, it's an address, you can see it is not a private key. So again, like I said, from your from address you can get the nonce. So nonce, like the number of transaction that has occurred on that address. So you're trying to get the nonce, so that's the next transaction that is supposed to occur on that address. So that's why you're sending your from address to get your next nonce, right? This is your next nonce, and from that, like I said, we're going to send 0.01 ETH. So like I said, 1 ETH is 10 raised to power 16, like from what we counted. And I also said again, for a normal transaction, for a basic transaction, 21,000 Wei is sufficient. So as is a sufficient gas limit, it ought not to pass that gas limit, right? So you can set a gas limit, and then you can get the suggested gas, right? So for something, if we want to just have a picture of it, we can just log it here. Let's say log dot print line suggested gas, and then we have gas price. So this is, let's just have a view of what the blockchain suggested for us to use as the gas, right? So like I said, you create your transaction. Don't mind this for now. They have depreciated this new transaction. There is you can read the documentation. It says use new TX instead, but let's keep going with this, right? Let's keep going with this. It's still gonna do the same thing, right? So you get your nonce, you pass your nonce here, your to address, that's my address that I'm going to send to, the value which was here, which we converted it to, which was Wei, and then we are going to, and then the gas limit which we set here as 21,000, and then our gas price which we got the suggested gas price, right? And then like I said, data is new. You're not really sending anything in, no information, no data there. You're just sending ETH from one address, from one wallet to another, right? And then chain ID, like I mentioned earlier, that chain ID tells you which network we are working with. Is it ETH Sepolia network? Is it ETH mainnet network? So if you want to have an ID, you can still log it here so you can see the chain ID for Sepolia network, right? Sepolia chain ID, sorry. Sepolia chain ID, so we can just see the Sepolia chain ID network, right? And then again, like I said, using that, you sign the transaction using your private key on that chain, on that particular chain. That's the chain ID, right? Once you sign that, here we are broadcasting it, and then we'll see and then I'm printing out the hash, the transaction hash, so that we can use it and go to our Etherscan and check it out, right? So now the question is, before you send a transaction, right? Yeah, for example, you need the money, you need at least this amount in the wallet. So how do we get that amount in our wallet? So let's see. Let's see this wallet, right? Let's MetaMask. So I already have 0.05 Sepolia, but like I said, Sepolia is a test net, so you can easily get the Sepolia test net from their test net faucet. So if you just Google free Sepolia ETH faucet, you should get options. So this is the one I used the last time. Let me see if I'm still eligible to just copy your address. Am I still eligible to get it? So if I do this, no, it's saying I should try again. It's once every day. So that's basically, let me see if I can get it from here, from Alchemy, yeah, Sepolia. So if I do this, post the address there, so I'm supposed to get a 0.1, verify I'm human, send. Oh, so this one says you must have ETH on your Ethereum mainnet. I'm not gonna fund it. I'm not going to fund the Ethereum mainnet, but you get the point. So basically, you can still check all of these. We check this. Sepolia faucets. Chain stack key. I'm not going to register for chain stack. Let me check this. So basically, we do I need to do this? So you can literally human. Can I do this? Man, just screw it, right? Screw it. So basically, we already have 0.05 Sepolia, which we got from here, but we can't get it again because, just to be fair, it gives once every day, right? So we can work with this. So the next we are gonna do is, and we are trying to send 0.01. Yeah, we have 0.05. Yeah, that should be enough. So, and again, we already know this is my personal address. Let's see if we can see it. So I can just go here. All right, so this is, I have 0.0296 Sepolia, right? That's what I have right now. So we're going to look at it in real time when we are sending it. So this should be +1, 0.01. Yeah, this should be +1. I should end up with 0.02, right? So let's do go run main.go. So that's the sender. Now, as you can see, we have sent this. So now this is a transaction hash. So this is sender. This is Sepolia chain ID. So if you do a quick search, for example, Sepolia chain ID, what is Sepolia chain ID? You can see 111551111. So it tells you that we are sending it to the Sepolia network. So now we can confirm this transaction. It's, like I said, this was the suggested gas that it asked us to put in there. So we can actually confirm this transaction. Did we get it? Yeah, let's just confirm this transaction on. We're going to have to reload this anyways, but let's confirm this transaction in our Etherscan. Like I said, you come to Etherscan. This is Sepolia testnet. So you can just put it there and search it out. This is the transaction hash. This is the block. You can see the block is from, it is from 00. You can see this is my 3. Now it's successful, right? Now it's successful. You saw the way it changed, right? You see it's from, you can see the address 713CO. That's where it's from, and it's going to D390. So if you see, day 390, yeah, day 390. So as you can see, it has reflected to 0.396, right? That is now it was 0.02 before, now it's 0.03. And here you can see it's changed from 0.5 0.005 to 0.04, right? Basically, I hope, and you can see we can also check out, look at the ETH, it's saying 0.01 transaction fees was there. We do have our gas price. This was what it this was what it took it to send a transaction. And this is the block in which it's the transaction is part of this block. You know, we discussed how blockchain is. A block contains transaction, so the transaction is in this block, right? So now I hope you have an idea of how the blockchain works in general, in how to from how to set up your blockchain, set up your wallet, get your private key, send, get, including getting spare Sepolia if you want to test, and then using your private key to sign your transactions, and then, you know, monitor your transaction using Etherscan. I hope I was able to enlighten you, and I hope I was audible enough and you learned. So please help me stay motivated by subscribing, liking, and sharing. It means a lot to me. Thank you very much.